This video is on theoretical and experimental probability. Now, most of this you will recall from last year, but we're going to stress some certain points that you need to make sure and understand this year. So, theoretical probability is used to find the probability of an event when all the outcomes are equally likely. So, go ahead and write this in your notes. Theoretical probability. Probability equals the number of ways an event can occur out of the total number of equally likely outcomes. And those outcomes are what you looked at yesterday with your sample space, how many outcomes you're looking at, and probability is looking at a certain thing that could occur. So like heads or tails, heads occurring versus is 1 out of 2 possible. So that would be 1/2 would be the probability. So a coin, die, or other object is called fair if all outcomes are equally likely. So a coin, of course, would be heads or tails. A die would be, a regular number cube would be 1 through 6. But let's say you had a die that had 2 number 1s on it, then that would make it different and it wouldn't be fair. A spinner where all the parts are equal is fair. So again, go ahead and write this and get this in your notes, and then we'll continue. Okay, so whenever you're writing about probability, you'll write P, or you'll see it written P, standing for probability, of the event represents the probability that an event will occur. For example, the probability of flipped coin landing heads could be written as P, as in probability, of heads, and it's in parentheses. And then you would write the number, usually in fraction form, but it could also be written in decimal or percent form. It will tell you which form to write it in. But if it doesn't tell you, just write it as a fraction form. So find the probability, write your answer as a fraction, as a decimal, and as a percent. So it wants you to do it all 3 different ways. Andy has 20 marbles in a bag. Of these, 9 are clear and 11 are blue. Find the probability of drawing a clear marble from the bag. So the probability of a clear equals how many are clear? 9 out of how many total? 20. So that's 9/20ths. This is how many you could get out of 20. And 9/20ths as a decimal, you would multiply by 5, and get 45 hundredths. So that's 45 hundredths, or 45%. And so let's check that. And it does say 9/20ths, 45 hundredths, or 45%. Find the probability, write the answer as a fraction, decimal, percent. Andy has 20 marbles in a bag. Of these, 9 are clear and 11 are blue. Find the probability of drawing a blue marble from the bag. So now I want the probability of blue. And blue is 11 out of 20. Now, this would be times 5 would be 55 hundredths, or 55 hundredths, and 55%. And what you might have noticed is if you took this and looked at the probability of clear, which was 9/20ths, 9 plus 11 is 20 out of 20. So that's to say that this is complement. So this is the probability that blue will happen. This, and then the complement is the probability that something else would happen. And I'll discuss that in a second. You can write that in your notes. So this is, of course, 11/20ths, 55 hundredths, or 55%. Okay, so find the probability, write your answer as a fraction, decimal, or as a percent. Find the probability of rolling a number more than 6 on a fair number cube. So probability of a 5 or a 6 on a number cube. Okay, so my number of outcomes for a number cube, for a regular number cube, is 6. I can get a 1, I can get a 2, 3, 4, 5, 6. So that's out of 6. Now I want either a 5 or a 6. So that is 2. And of course that simplifies to 1/3, and from your warm-up yesterday, you know that's 33 hundredths and 33 1/3%. So you've got 33 hundredths, 33% and 1/3. So there are 13 boys and 10 girls on the track team. The name of each of the team members is written on an index card. A card is drawn at random to choose a student to run a sprint, and the card is replaced in the stack. Find the theoretical probability of drawing a boy's name. So the probability of a boy's name, and how many boys? There's 13 out of the total, because they're all combined, they're all in that together. So that's 23, and we don't have to write it as a fraction, decimal, and percent. This is boys and girls. So we don't have to write it as a fraction, decimal, and percent, just as a fraction, because, well, one, this doesn't convert easily, and two, it doesn't ask for it. So 13 23rds, probability of boy. Okay. And so now, the thing you need to write in your notes is the sum of the probabilities of an event and its complement. So the probability that something's going to happen and that it's not going to happen is 1. So write this in your notes. Okay. A teacher has written the name of each student on a piece of paper and placed the names in a box. She randomly draws paper to determine which student will present the answers to the problem of the day. There are 15 boys in the class of 27 boys. The theoretical probability of a boy's name will be drawn. So the probability of a boy, and there's 15 out of 27. So that's the probability that a boy will be picked, and then the probability that a girl's name would be drawn would be 12 out of 27, because 15 plus 12 equals 27, and that's how many girls are in the class, because there's 15 boys, and so it would be 12 27ths. Sarah has 30 gumballs in a bag. The bag contains 10 red, 7 green, 5 yellow, and 8 white. If she selects one gumball at random, what is the probability of it being red? So there are 10, so probability of red, there's 10 red out of 30, and I'm going to simplify this. 1/3 equals 0.33 and 33%. And what is the complement of red? So if 10 are red, then of not being red would be 20 30ths, and that would be 2/3, which would be 0.66 or 66%. And what's the probability of not being red is the same as asking what's the complement of red. It's what's not being red. So the second part of this is experimental probability. Now the only difference between theoretical probability and experimental probability is theoretical is given everything's equal, we see this could happen. Experimental is based on what really did happen. And so it's the likelihood of an event being repeated in an experiment many times, observing the number of times that it happens. The number is divided by the total number of trials. So now it's not outcomes, it's trials. And the more an experiment is repeated, the more accurate the estimate is likely to be. So the probability, the number of times an event occurs over the total number of trials. So you need to write that in your notes. And this is experimental. Experimental probability. And this just means it's an estimate. Okay, so during skating practice, Sasha lands 7 out of 12 jumps. What's the experimental probability that she will land her next jump? So it's the probability of a jump, and what she's used to is 7 out of 12. So that if that were to continue, that's what the experimental probability would be. It would be 7 out of 12. During a basketball game, Martha needed to make 9 out of 10 free throws. What's the experimental probability that it would be on her next attempt? 9 out of 10. And this is the probability of a free throw. And that would be 9/10 or 90/10 or 90/100 or 90%. And that would be that. Okay. Students have checked out 55 books from the library. Of these, 32 books are fiction. What's the experimental probability the next books will not be fiction? So this is actually the complement of the fiction. So 32 are fiction, 55 are non-fiction. So subtract those and get 23 out of 55. And of course, we're not going to change that because it doesn't neatly go to a decimal or a percent. Students have fruit choice for lunch, apple or pear. So far, 18 out of 47 have selected pears. And so 18 out of 47 would select a pear, probability of a pear. And this is, of course, experimental probability, and 18 out of 47. And then this is asking the probability of an apple. Well, that's just the complement of the pear. Since 18 chose pear, then 29 would choose apple. So probability of apple would be 29 out of 47. And so that's just the difference between experimental and theoretical. We're primarily going to focus on theoretical, but I didn't want you to be thrown if you were asked about something experimental. So now you're going to work on your worksheet and get your homework for theoretical probability.